All right. So we are continuing our lesson 5-2, verifying trig identities. Yesterday I asked you to do 3B, and we will check it right now. Got my stuff all mixed up. All right. So, which side did you start with?
Left side.
The left side, the fraction. All right, and we're trying to get to cosecant x plus cotangent x, so you got to keep that in mind too. So, we're starting with sine x over 1 minus cosine x. So, what did y'all try?
Multiply by opposite.
To conjugate?
Yeah.
Yes, that's what I did too. There's really not anything here that's beneficial. So if you have a binomial denominator like that, because that looks very similar to Pythagorean, doesn't it? So if I multiply by a conjugate, I'll probably get a Pythagorean identity. So I'm going to multiply by 1 plus cosine x, 1 plus cosine x, because whatever I multiply the numerator by, or the denominator by, I have to multiply the numerator. So here, I'm just going to bring this over. I'm not going to distribute this at this point. So sine x times 1 plus cosine x. But then on the bottom, I want to multiply these conjugates together. And remember, when we foil two binomials that are conjugates of each other, the middle terms will cancel out. So you end up with 1 negative cosine times positive cosine is negative cosine squared x. Because the negative cosine x and positive cosine x would cancel each other out. So now I believe 1 minus cosine squared is an identity. Yep, there it is right there. 1 minus cosine squared is sine squared. So sine x times 1 plus cosine x over sine squared x. Okay, so now what?
You can mark out one sign on the top.
Okay, I can cancel out one of the sine x. So this one cancels out, and this one now I just have 1 sine x. So I have 1 plus cosine x over sine x. So now what?
Make it two different separate fractions.
Good, Corey. Make it into 2 separate fractions with the denominator sine x. So 1 over sine x plus cosine x over sine x. So what's 1 over sine x? Cosecant x. What's cosine over sine?
Cotangent.
Cotangent x. And is that what we are supposed to get?
Yeah.
Wait, where's the cosine at? Oh, no.
You want to delete this recording?
No. Let me go back and look.
Looks like it's the right answer. What's wrong with it?
Oh, I was looking at this up here. I was looking at the wrong one. Here, cosecant x plus cotangent x. Yes, that's what I wanted. Okay, I looked way up at the top to compare. I was like, that's not what we got. Okay, it makes me feel better. I don't even to worry about myself there. All right.
Might have to redo the recording. Hello, YouTube.
Now, example 4a, we want to verify that cosecant x, secant squared x, tangent x, minus cosine x, tangent cubed x. That's all should simplify. Let me start over. All of that should simplify to sine x. Okay, so we're going to start with the left side. So we have, I'm just going to rewrite cosine x, secant squared x tangent x, that's all one term right there, minus cosine x tangent cubed x. Now, just looking at this, there doesn't seem to be a lot that we can do with it. We could go ahead and write that as 1 over cosine if you wanted to, or 1 over cosine squared. But I think I would just go ahead, and if you notice, there's 2 terms here. And remember when we did greatest common factor, factor out of GCF, what they have in common? You can look and see that here we have a cosine in common, and we have 1 tangent in common. So I can factor out a cosine and a tangent. So basically, I'm dividing by cosine tangent. Cosine tangent. All right, so those cancel out. So what do I have left on the left side?
2 tangents.
No, on the left side.
Oh, secant x.
Secant squared x. All right, and then what do I have over here on this one?
2 tangents.
Right, one of the tangents would cancel out, so I have tangent squared x. All right, so now look at your identities, because I have some squared terms here, 2 of them, so maybe there's an identity for that. Exactly. If you look right here, secant squared minus tangent squared is just 1. So this whole thing can be simplified to 1. So we have cosine x times tangent x times 1. So what's cosine x times tangent x times 1? Cosine x times tangent x. All right, but I'm still not down to sine x. So what do you think we might do now?
But tangent x is sine over cosine.
Rewrite tangent as sine over cosine. So we have cosine times sine, cosine x times sine x over cosine x. So we're multiplying, so these 2 cancel out, and what do I have left? Which is what I should have gotten. All right, now before we do 4B, I want to go back and do a problem from regular algebra to review a factoring technique we haven't used in a very long time. Okay, so I want to look at this problem. D cubed plus 2D squared plus 4D plus 8. Now, if we were going to factor this, we would want to see if there's a greatest common factor for all 4 of them, all 4 terms. Is there a greatest common factor?
1, 2. No, there's not.
No, there's not. Okay, so if you have 4 more terms, there's a technique called grouping. Okay?
Yeah.
And so what you want to do is group
Pretty sure we did that last time.
2s. Yeah, it's been a while, but we've done it. So
D's out of that.
now what factors out of this?
D squared.
D squared. And so what do I have left?
D plus 2.
Okay. And then what factors out of this?
4.
4. And what do I have left?
D.
All right. So now I have 2 terms. I've gone from 4 to 2. And they have something in common. What do they have in common? So I'm going to factor it out. And what do I have left?
D squared.
And that would be completely factored. Okay? So, we're going to use the same idea here. We've got this big long string of stuff, and it's all supposed to simplify all the way down to sine x. So, let me write all of it down. Here's the first term is cosecant x, minus the second term cosine x cosecant x, minus the third term cosine x cotangent x, plus the last term cotangent x. So you've got 4 terms here, 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 here. And do all four of them have anything in common?
Yeah, X?
No, you can't take this cotangent. The X is not by itself. It's
Then no.
no. All right, so let's try grouping. Let's do these two and these two. So what do I have in common with these two terms? Cosecant x. So factor out a cosecant x. So that means I'm dividing both of these by cosecant x. So what do I have left here? Yeah, I do. 1, good. Because cosecant x over cosecant x would be 1. Minus, and what do I have left here? Cosine x. Now, what do we have in common here? Cotangent. Now, when I first started working this, and I'm going to save us a little time here, I factored out a negative cotangent. Then when I got to the end, or got through, and I was trying to factor out a 1 minus cosine x, my signs were off. Okay? So, on this one, you're going to need to factor out a positive cotangent, and you'll see why in just a minute. Now, if you're doing it on your own, you can just do what I did, try it and see.
So how can you factor out a negative if none of the cotangent?
You can factor out a negative cotangent, and that would make this term positive and this term negative. So, I factored out a positive cotangent x. So what do I have left on this side? Negative cosine. Now, if I had factored out the negative, that would have been a positive cosine left. All right. Now, what is cotangent over cotangent? Now, look at what we have right here and here. Are those the same?
Oh, well, yeah.
Yes, both the cosines are.
Yes, these are the same because I have negative cosine x and a positive
They
1.
cancel out.
Okay, no, we're going to factor it out because we've got these two terms here. This isn't, we're not dividing, so you can't cancel them out. So, we're going to factor out a 1 minus cosine x. No, it's not going to be gone. It's right here. And so what do we have left in this term? Cosecant x. What do we have left in this term? Cotangent x. See, if you'd factored out a negative here, you would have ended up with cosine x minus 1, which is different than that. Okay? So you would have had to rework it. All right. So now what do I do?
Cotangent over sine.
All right. Let's go ahead and do that. Since we're working towards sine, we know cosecant can be written with the form of sine, right? Because it's a reciprocal. So let's do that with these two. So let's leave 1. I'm just going to put this in parentheses. 1 minus cosine x alone. Now, how would I write cosecant x? 1 over sine x. And how would I write cotangent x? Cosine x over sine x. And, luckily, we have a common denominator, which means I can just write the numerator over that common denominator. So I have 1 minus cosine x. I'm just bringing it down. And then I have 1 plus cosine x over sine x. Now, what do I notice about these two? Conjugates. So why don't we just multiply straight across? So put that over 1, because we had two fractions we're multiplying. If you want to put the multiplier in between, you can. All right, so these are conjugates. So 1 times 1 is 1. Negative cosine times positive cosine is negative cosine squared over sine x. And I bet 1 minus cosine squared is an identity. Good. Sine squared. And if you need to write it separately so you can see what you're canceling out, you can, but you don't have to. Because sine squared x is the same thing as sine x times sine x. So you'd have 1 sine x cancel out, and what do you have left? Which is what we were looking for. Okay. One more. And then y'all get to do something. Now you'll notice that the heading here says verify an identity by working each side separately. What that means is we kind of have two complicated things going on here. We've got a fraction on both sides. So what you can do is you can take one side and simplify it as far as you can. Then take the other side and simplify it and see if you can get what you got with the first side.
Yeah, tangent
kinda-
squared.
you kinda meet in the middle,
Tangent
okay?
squared to secant squared minus 1.
All right, hold on, Wesley. You're getting ahead of me. So let's start with the left side. So the left side, we have tangent squared
Secant
x
squared.
over 1 plus secant x.
Yeah.
All right, so Wesley's already seen that there's an identity for tangent squared x. It can be rewritten as
Secant squared
x minus 1 over 1 plus secant x. Now, go back a little algebra here. If we have x squared minus 4, those are two perfect squares. So it's a difference of squares. So you would take the square root of each, put a plus and a minus. X plus 2, x minus 2. Secant squared x minus 1 is a difference of squares because both of these are perfect squares. So that will factor into secant x plus 1, secant x minus 1. So it makes the conjugates. It factors into the conjugates. And if you foil it back together, you'll end up with that. So you have 1 plus secant x on the bottom. So now what can I do?
Cancel out secant x plus 1 and 1 plus secant.
Yep. And so what do we have? And that's probably about as simplified as we can get that. So now what we want to do is take the right side and see if we can end up with secant x minus 1. If we do, then we verified. So you're kind of working from both sides and meeting in the middle, if you want to think of it that way. All right, so the right side is 1 minus cosine x over cosine x. So what do you think we ought to do here?
What's that?
By what?
Cosine of 1.
Cosine over 1?
No, we're just gonna.
Well, my first inclination was, well, maybe, well, that's what I thought too. But I'm trying to get to secant. What do I know about cosine and secant?
They're conjugates.
Or reciprocals. So this could be rewritten as two fractions. 1 over cosine x minus cosine x over cosine x. And what's 1 over cosine x?
Secant x.
Secant x. And what is cosine x over cosine x? Oh, there it is. Now, you could have multiplied by the conjugate. I mean, I would have to do it to see. You probably eventually get it. But if you do it this way, you can see it. You get it pretty quickly. And that's what I say. This takes some thinking. This takes some reasoning. It may take some trial and error. All right.
Well, that concludes our pre-cal lesson for today. A good.
Okay.
To
So your assignment, I'm writing this up here more for the video, is going to be verifying Trig Identities 1, and it's going to look like this.
And that's pre-cal teacher MD signing off. Goodbye, everyone. Can they hear me from here?